Today, we're going on a journey deep inside an oil refinery, and our mission is simple: to figure out how one single substance, that black, goopy crude oil, gets transformed into the fuels that pretty much power our entire world. We're talking about everything from the gas in our cars to the very roads we drive on.
I mean, think about it for a second. It sounds kind of impossible, right? The gasoline for your car, the gas that cooks your food, and the thick black tar used for roads. How on earth can they all come from the exact same raw material? Well, that's the big question, and we're going to unpack it right now.
So let's start at square one. You see, crude oil, straight out of the ground, is surprisingly, well, useless. You can't just pump it into your car or a jet engine. In its natural state, it's just this thick, messy jumble of all sorts of different molecules. I want you to picture a giant bag filled with all kinds of nuts, bolts, and screws, all different sizes, all mixed together. Before you can build anything, you've got to sort them out first, right? Well, in crude oil, those nuts and bolts are called hydrocarbons, and the first job of a refinery is to be a master sorter.
So how in the world do you sort something on a molecular level? Well, the answer is a really clever bit of science called fractional distillation. Honestly, this is the golden rule that makes the entire modern oil industry possible. And the secret weapon here is a concept you probably remember from science class: the boiling point. See, every single one of those different hydrocarbons in the crude oil mixture has its own unique temperature where it gives up being a liquid and turns into a gas or a vapor. And believe it or not, that simple fact is the master key to unlocking everything inside.
Okay, so here's where it gets really important. The lighter hydrocarbons, the smaller molecules, they turn into vapor super easily at pretty low temperatures. But the big, heavy ones, yeah, they're stubborn. They need a lot more heat to get going. This huge difference is what we exploit in the whole process. Now, turning them into a vapor is only half the battle. We've got to turn them back into useful liquids, right? And that process is called condensation. It's the exact same thing you see happening on the outside of a cold glass on a hot day. The water vapor in the air cools down, and bam, it becomes liquid water again. Simple as that.
All right, theory time is over. Let's get our hands dirty, so to speak, and step inside the refinery. The whole show really comes down to two main pieces of gear: a gigantic furnace and a super tall distillation tower.
First things first, you need heat, and I mean a lot of it. The crude oil gets pumped into a furnace and is heated to a seriously scorching 450 degrees Celsius. To put that in perspective, that's more than twice as hot as your home oven can get, even on its highest setting. So it all kicks off with this simple three-step process. The oil goes in, it gets superheated until it's this churning, boiling mix of liquid and gas, and then this volatile mixture gets blasted into the very bottom of that tall distillation tower, and that's when the real magic starts. All right, we are now inside the heart of the operation, the fractionating column. In here, all those different hydrocarbon vapors are about to go on this epic climb that's going to decide what they grow up to be. The design of this tower is just pure genius. It's incredibly hot, way down at the bottom where all that vapor rushes in. And it gets cooler and cooler the higher you go. This gradual change in temperature, this gradient, is what forces all those hydrocarbons to go their separate ways. And here's what happens. As that big cloud of hot vapor starts rising up the tower, it begins to cool down. As soon as a specific hydrocarbon vapor reaches a level in the tower that's cool enough to match its boiling point, it condenses back into a liquid and gets collected on a special tray. So the lightest fuels, like LPG, they make it all the way to the cool air at the top. But the really heavy stuff, like tar, it pretty much stays put right at the hot bottom.
Okay, so after all that drama, the heating, the rising, the cooling, what are we left with? Well, we're left with a whole family of separated products. Let's meet them, starting right at the very top of the tower.
Way up at the very top, where it's coolest, we collect the lightest of all the fractions: liquid petroleum gas, or what you and I call LPG. These guys have the lowest boiling points of all, so they traveled the farthest.
What we do is capture this gas and put it under pressure, which turns it into a liquid. You'll know it as the stuff that fuels your barbecue, heats some homes, and even powers some cars.
Okay, let's head a little bit down the tower now. Here, in the upper middle section, we get to maybe the most famous member of this whole family: petrol, or as it's known in many places, gasoline.
It turns out these medium-sized molecules are just perfect for powering most of our cars. Now, a little secret, the gasoline that comes out here isn't quite ready to go into your car just yet. It usually needs a bit more processing to get the performance we all expect at the pump.
All right, heading down to the middle of the tower, things are starting to get a bit hotter. And here, we collect something heavier, something more packed with energy, kerosene.
And wow, this is some powerful stuff. After a bit more cleaning up, this becomes the jet fuel that lets us fly all over the globe. It's also used in all kinds of heaters and stoves around the world.
Okay, we're going even further down now, where it's getting seriously hot. And this is where we find the real workhorse of the fuel world, diesel.
See, diesel is made of these much bigger hydrocarbon molecules, and they are just crammed with energy. This is literally the fuel that powers our economy. The trucks, the buses, the trains, and all the heavy machinery that builds our cities and moves our goods.
And at last, we've hit rock bottom. Literally, the bottom of the tower. So what's left behind after everything else has boiled away? Well, it's tar. Or, as you might know it, asphalt.
This thick, sticky gunk is basically the leftover residue that was too heavy to even start the climb up the tower. But it turns out its super thick and durable nature makes it absolutely perfect for one thing we all rely on, paving the very roads we drive on every single day. So, there you have it. We went from a messy, useless black goo to this perfectly sorted family of products. From the gas that powers a jet plane high in the sky to the very asphalt on the runway beneath its wheels, it all starts from that one single drop of oil, all separated by the simple, elegant physics of heat. So next time you're on the move, you'll know the incredible journey it took to get you there.